Part 1 includes globals, board, score, shapes, and piece structure. This part prepares everything the game needs before it can run. First, header files. IOStream used the pointing text to screen count. Konyo Point H used Getch and KB hit for instant key input, no enter needed. Windows Point H used for sleep, console color, and clearing screen. CST dlib or ctime for randomness for shape selection. Second, game board settings. With 35 columns, height 40 rows, board 2D array representing the interplay field, 0 equals to empty, any positive number equals to color of stored block. This is where all fallen pieces are stored permanently. Third, score variable stores the player's scores. In your code, you add 100 points for each cleared line. Fourth, color function. Fifth, Tetris shapes or tetramenus changes the text color of your console using Windows API used to color pieces differently. This is a 3D array, first index which piece I, O, T, J, L, S, Z, second and third shape layout, 4 times 4 grid, example I piece. The first mark where the blocks are. Sixth, current piece structure. A falling piece has X left position on board, Y top position on board, type, which shape 0 to 6, current is the piece now falling on screen.
Okay, let's proceed to the next part of our report. It's all about void drawBoard. This line declares the function names drawBoard. It takes no arguments or void and doesn't return any value void. Next is system or CLS rather. This time, clear the console screen. It's a system dependent command or work on Windows. It ensures that the previous frame of the game is declared before drawing the next one. In first count, this line print the game control to the console, informing the player how to interact with the game. And the second count is this line display the current score of the game. It assumes you that the variables named score the hold the player's goal. The -n and -n add two new lines for spacing. Let's proceed to the margin equal 20. This line defines an integer variable margin and initialize it to 20. This variable is used to add left and right margin to the game board when it's printed on the console. For int m equals 0, m greater than margin m plus plus, close parenthesis. This loop print a series of space to create a left margin, followed by a line of double like that, characterized to form the top border of the game board, and line move to the cursor to the next line. For int y equals 0, y greater than height, and y plus plus close parenthesis. This is the main loop that iterates through each row of the game board. Height is likely a constant that defines the number of rows in the board. For int m equal 0, inside the outer loop, this part add the left margin and prints to start the left border of each row. For int x equals 0, x greater than width, and x plus plus close parenthesis, with the inner loop iterates through each column of the game board. Width is likely a constant defining the number of columns. The next is in the if. This if statement check in the current cell board x and y is non-zero. A non-zero value is board y and x indicates that the blocks from a previously falling piece in present at that location. Set color board x y. If the cell is non-zero, this line call function set color close parenthesis to set the console next color based on the value stored in board x and y. This allow different blocks to have different color. And the next count like this one. This print to represent a fill block on the board. Second, set color 7 and close parenthesis. This resets the console text color to the default color, usually light gray. The next one is else. This else block is execute in the current cell board, the x and y is 0 or empty. And next one is bool part. A boolean variable part is initialized to false. This variable will be used to track whether the current cell is part of the current falling piece. And for the next one is for. If this nested loop iterate through the 4x4 representation of the current piece or shape current type, check for the cell of the current piece type of blocks. Current y plus I equal double equal y and current x plus g. And the next one is the set color. If both condition is the if statement are true, it means that the current cell on the board is part of the currently falling piece. Set color. Set the color for the current piece. The +9 is likely an offset of differentiate the color of the falling piece from the color of the blocks already on the board. The next one is count print to represent the blocks of the falling piece. Set color 7. Reset the color of the default rather. After checking all the blocks of the current piece, the part variable is still false. It means that the current cell is empty and not part of the falling piece. In this case, it's print two spaces to represent an empty cell. Next is, after iterating through all the columns in a row, this line print to complete the right border of the row and then move to cursor to the next line. And the next one is to set color. If both condition is the if statement are true, it means that the current cell on the board is part of the currently falling piece. Set color. Set the color for the current piece. The +9 is likely an offset of differentiate the color of the falling piece from the color of the blocks already on the board. The next one is count print to represent the blocks of the falling piece. Set color 7. Reset the color of the default rather. And the last is 4. After iterating through all the rows, this part print the bottom border of the game board similar to the top border.
Once again, I'm Angel Manugot, and let's continue. Check collusion. So what is the purpose of check collusion? So check if the piece hits something from wall, floor, or another block. How it works. So loop through the 4x4 matrix of the current tetromino shape. Every one in shape, there's P that type IJ is a block of the tetromino. Next, convert local possession I, J into board possession NX and NY. Collusion happens if NX is less than 0 hits left a wall. NX is greater than is equal to width hits right wall. NX is greater than is equal to height hits the floor. So the board NX and Y is equal to 0 hits another place, a piece already a place. Next, the piece. So what is the purpose? So lock the piece into the game board when it can't fall anymore. How it works. So loops the 4x4 shapes again. For every block part, there's one. Write it into board NX and Y. Uses P.type +9 to color or mark the block. So basically, the falling pieces becomes part of the board. Next, the found piece. So what is the purpose? So it's create a new tetromino after placing the old one. What it does. So random shape, the current that type is equal to R and open parentheses, close parentheses, the present num and shape. Next, start at the top. Current that Y is equal to 0. Next, center horizontally. Current that X is equal to open parentheses with -4, close parentheses, /2. Next, clear line. So what is the purpose of clear line? So check if a line is full, then remove it and shift everything down. So how it works? So start from the bottom. Second, for each row, check if every cell has a block. Next, if even one is 0, not full. When a full line is found, add score. So score plus is equal to 100. Next, move every row above it down by 1. Next, clear the top row because everything shifted down. Next, Y++ lets the loop checking the same row again. Important when clearing multiple lines. So in summary of that 4, so collisions is check if moving or rotating the piece hits something, while the place piece locks the pieces on the board after it lands. The spawned piece create a new tetromino at the top. And the last one, clear lines. So remove filed lines and shift rows down. That's the end of my report.
So I will discuss the rotation. The function appears to rotate a space, shape, either clockwise or counterclockwise, and handle collision direction during the rotation. So the code rotate 4 times 4 shape clockwise, and if the rotate shape cause a collision, it revert to the original shape. So there are 4 steps. First, store original, save the internal shape in the temporary array. The second is rotate. Rotate the shape 90 degrees clockwise during the shape. The third one is click collision. Detect if the rotate shape with anything. So the last one is the prevent if collision. If the collision is detective to the shape, is the restored to its original form or temporary. So in the essence, it's a rotate and click it. Ensure the shape doesn't cause invalid or replacement. The approach ensure that rotation only occur and invalid.
Part 5. Game Loop. This part contains the core logic that runs continuously to keep the game active, handle user input, and update the game state. Step-by-step breakdown. First is we have initialization. So in initialization, we have shrunk for time, spawn for new piece. It's the number generate for the correct time for buried piece shapes. Call spawn piece to generate the initial failing piece. The second is game loop starts. So in game loop starts, runs an infinite loop while true to keep the game running. Uses sleep 50 to control the loop's speed, making it run roughly every 50 milliseconds. Counter keeps track of elapsed time to decide when to move the piece down automatically. The third one, so handle user input. So in handle user input, we have check if the key has been pressed, reads the key width, creates a temporary copy of the current piece, and then adjust its position or orientation based on the key. So on the key, we have Z move for left, M move for right, N move for down, and X for rotate. Use check collision to verify if the move is valid. If no collision updates current to the new position orientation. Take note, this allows real-time to control, ensuring the players can move or rotate the piece without conflict. In number 4, automatic downward movement. So in downward movement, when enough time has passed counter speed, the piece is moved down automatically. Resets counter to 0, create a temporary copy temp, and moves it down. Check if moving down causes a collisions. If no collision updates, control to the new position. If collision occurs, hits the button or another block. Calls clear line to remove completed and update the score. The code is incomplete where, but typically it would spawn a new piece afterward. So in summary, the game loop runs indefinitely, updating every 50 milliseconds. It processes user input to move or rotate the current piece. It automatically moves the current piece down at interval defined by speed, when the piece can no longer move down in any complete line. This loop continues, creating a dynamic and interactive Tetris game.